Monday's lesson on cosine law and areas of triangles. We'll start with cosine law. Cosine law is a law for finding the area of triangles. When the sine law doesn't work, there are certain combinations of givens for which the sine law will not work. For instance, one like number 27. 27 in your assignment, you are given this, and that won't work well for the cosine law at all, because with the, for the sine, it won't work for the sine law because you are never given an angle and the side opposite it. In this one you're given kind of a side angle side, but this will work nicely for the cosine law. Cosine law is given in your book on 295. And it's like given three ways. Now, of course, you may have these written on a card and understand that the cosine law assumes that little a is opposite angle A, little b is opposite angle B, and a lowercase c stands for side C, opposite angle C. It assumes that arrangement, which is kind of standard in most textbooks. I think it would be helpful though to first of all look at these three different rearrangements of the cosine law and tell me what you see that is similar in every one. See any patterns there? What can you see is the same happening every time? Spot anything, Mitch?
Well, they all look similar.
They all look similar, my man says. Okay, let's see if we can get a little deeper than that. Luke is laughing. Luke obviously sees much more. Luke, have you noticed anything else about how each of them is in some way the same?
The angle that you're trying to find is what you take the cosine of, or the side that you're trying to find is the angle you take the cosine of.
I think what Luke is saying is he has noticed that side A, when it's to the left here, you have angle A as the angle you're taking a cosine of. So these letters, front end, back end, match every time. My man Luke has noticed that. There's other things to notice, and I've got some keen eyes out there, and I'm thinking maybe Caden sees something else. To Caden, the rest is just a scramble. Right. Just saying to my 8th hour class, the 2nd hour class wakes up slow. I'll just help them out. I'm sure 8th hour class all sees this already and is just moaning and groaning. But notice that if you have one side over here, you have the other two sides here and here, and repeated here every time. Whatever side is not here, it is here and here, and repeated again here and here. So you should notice that also. If you notice those 2 or 3 patterns in this, you almost don't need a card. And if you do enough of these, I think you'll soon find yourself just writing it out without looking at your card. But you may have a card. Let's now apply this to this problem number 27. Obviously, we're going to have to do the cosine of 42. So this angle that we're trying to find, we can just assume is going to be this one. I mean that side we're trying to find. So in number 27, what's the name of that? 27. Yeah, 27, that's angle A. So we're trying to find side A. The easiest or the way to begin this is go for side A. This first formula is the one for this. So we're going to go like this. A squared equals 12 squared plus 19 squared minus 2 times 12 times 19 times the cosine, and this has to be cosine of the angle opposite the side you have way over here. So this is all sitting nice now. Now from there, we can calculate this all on the calculator. So for requiring work, for the teacher requiring work to be shown, I only require this step. A lot of you will write more. Sometimes you like to reorganize it a little bit, but I only require the setup. So if you're going to be showing work, I'm asking for this one. More is great, but this step right here is required. My camera lady is now going to pan over to Connor's calculator. Connor is going to try to put this in his calculator just like that. You have it already, Connor?
I think so, yeah.
All right. What do we have to remember?
The degrees.
Did you?
Probably not.
He is now double checking to make sure he's in degree mode. If that angle's in rads, you better be in rads. Today it's going to be mostly in degrees.
Yeah.
All right. Is this what you have in, Connor, just like that?
Yeah.
So if you push an enter on that, just to check them everybody else so we all get the same, what do you get there?
I got 687.393.
187.39. All right, so then you'll have to do a square root, right?
Yeah. All
We
right.
didn't get that.
You didn't get that?
Nope.
Whoa, we've got dissension among the ranks.
I get to make one, I just cut it.
We got 166.125.
Plus 19.
Connor's trying it again. Camera lady, did you see what you had in there? You put it all in just like that.
That's my answer.
You got the little squares on there?
Did. 12 squared.
Nate, what'd you get?
166.
That's back.
How?
Yeah, that's what I got.
Just go with it.
Get in degree mode.
I just switched it. Yeah, I got 166. It must have been the rest.
Yeah, Connor, close.
My assistant has changed his answer to what?
166.126.
Which makes a what?
12.8.
12.8.
12.8.
88.
Well, it's 8, 8, 8, 9, 8.
Got round up.
Wait, did you round down, Connor?
No. I just put 12 in.
All right.
It's okay.
When you decide on the answer and you start filling out your solved triangle, remember that to at least look it over to see if it looks reasonable. I've had people write down 166 for that side. I mean, look at this triangle and remember that no side can add up to more than the other two sides. Remember that big sides are always opposite the bigger angles, and it only takes a glance to check that. So if you put down 166 for your answer, you didn't even open your mind a little bit to a quick check, you know what I mean? So now, once you get it this far, you could quickly finish solving the triangle with the sine law. You could do something like this. The sine of 42 over 12.89 is equal to the sine of x over 19, and you should be able to find that missing angle. But that goes back to Friday's lesson. So once you get the first thing with the cosine law, you can always finish with the sine law. The cosine law can be used another way. It's nice for the given side angle side, because you can't use the sine law on that and don't have any side with its opposite angle. There's another kind of problem where the cosine law is very handy. Getting ready to erase this. Get a good picture of that. All right, it's coming down. Cosine law is also very handy for one like number 28, where you're given the sides, no angles. Number 28, you're given x is 5, y is 18, and z is 14. So I'll just put a... In fact, just to make this, just to show you what's possible, I'm going to take the picture away.
Whoa.
Yeah, yeah. The mind is an amazing thing. God has made your mind capable of seeing things without actually seeing them. So I'm going to put down x is 5, y is 18, and z is 14. Well, that's kind of useless now. We don't even have x, y's, and z's in our formula. You might be getting scared. No, we can do it. We can do it. What we have is all three sides. It's like having the A, B, and the C, you know. Doesn't matter what they call them. So we can use this style. Whichever one we place on the left, that's the angle that we'll be able to find, you see. So when I start like this, I am apparently putting x, side x first. That means I'm going to end with cosine of angle x. So I'm going to put big X there because angle x will be opposite side x. Notice the match, there. Also understand, would it matter if these two were traded around? If you did 18 squared plus 14 squared or 14 squared plus 18 squared, would that even matter? Would it matter if you went 2 times 14 times 18 or 2 times 18 times 14? So swapping them, the B and C, or the two sides, that won't ever matter. Swapping around here, that could mess you up. Now this one, Connor won't be able to punch directly in his calculator unless he can see 3 steps of algebra in his head. Somebody laughed. I did not. I'm going to do this in several steps, though I'm pretty sure Connor could do it in less. The first step of algebra would just be taking 18 squared plus 14 squared from both sides. Then it would look like that, right? Remember, our goal is to get this alone eventually so we can solve for it. The next step would be what, Luke? I'm just trying to algebraically get the unknown part alone.
Oh, then divide by the thing 2, 1842.
So you're saying I should, on my next step, have 5 squared minus 18 squared minus 14 squared divided by what?
All but the cosine of x.
Negative?
Yes.
You would be surprised how many people want to take that negative off there. I think they're thinking, like when you move this one across, the negative, it turns from positive to negative. So they think when you move this one across, it's a change, but we're dividing, we're not subtracting, right? So now I feel like Connor could put this in his calculator. Connor, just to be safe, I would put parentheses around the top and the bottom like that. Alright, zoom in on his calculator work there, Avery. I don't know, ask Avery, she's pretty good at seeing these things. She's made every mistake you can make.
Yeah.
She thinks it might work. So when you enter that, Connor, what are you getting?
0.982.
0.982 is the cosine of x. Does that agree with the audience?
Yes.
All agrees with Colin. What more do you need? All right, we're still not finished. The angle is not 0.982. That's the cosine of the angle. What kind of move, Matt, would a person make to find which angle has a cosine of 0.982?
I don't know, I just got here.
Matt is trying to sound like he was just born today. I'll ask Laura. Laura, 0.982 is the cosine of the angle. How can we figure out what angle has that for its cosine?
Cosine -1.
Ooh, Connor, can you do the inverse cosine of answer?
Yep.
Show Avery what that looks like on the calculator. And then when you enter that, what do you get?
10.844.
10 point what?
844.
And since you're in degree mode, that is degrees. All right, before we write it down, we want to do that visual mental check over, see if it's reasonable, you know. Jordan, remembering the fact that small angles are opposite small sides, big angles are opposite big sides, does it seem reasonable that opposite side x here there might be a 10.8 degree angle? She thinks it sounds quite reasonable and believable. So then you write it down, and now again you can finish with the sine law and get the other two angles. But some of you aren't even experts with the sine law yet. That'll come in the next day. 2 more things to show you. Keep the camera rolling. Did you get a good shot of that? He's got it. You can also find areas of triangles that are not right triangles. Nice right triangles, area is 1/2 base times height. In fact, any triangle, area is 1/2 base times height. But the ones we're looking at, we don't know the heights. So here's a couple other ways you can go. You can use Herons' law. Herons' law has the area equal to the square root of S times S minus A times S minus B times S minus C, and S is the half perimeter. The perimeter of a triangle would, of course, be all three of its sides added together. Cut that in half, and you have the S they are speaking of, sometimes called the semi-perimeter. Let's apply that to number 37. Yep, doing that assignment for you again. I don't know why I'm so soft. I know. In number 37, somebody's getting brownie points on camera. That should be worth double, right? 9, 11, and 16. We don't even need a picture. It's just a three-sided triangle. We'll just use Herons' law. The area will be equal to the square root. We better find our S. It's half the perimeter. 9, 11 is 20, 36. Half of that, 18. I'm putting 18 in the S spot because S is half the sum of the sides. Making 3 parentheses. Notice each parentheses is the semi-perimeter minus each of the sides. So I have to do 18 minus 9, bam. 18 minus 11, bam. 18 minus 16, bam. Connor will now put that in his calculator. Do you know how to set up the square root of those 4 numbers times each other?
I think so.
He's thinking that should be doable.
Yep.
Show Avery so she can get a pic of that. All right, hit enter and see if you can find that for me.
I got 47.624.
Is that before the square root? You did the
Yeah,
square root.
that's-
That's everything, right?
Yeah.
47.624.
624.
All right. Audience agrees? Audience agrees. One more, and then we'll conclude our lesson of the day. There's another way to find the area of a triangle. The other way is to use the kind of a sine law. That's where the area is equal to 1/2 base times height times sine of the angle between the, no, 1/2 side, 1/2 leg times the sine of the angle between the legs. I should give you a picture with that one, maybe. If you have a triangle where you know a side, maybe I have a sample to do for you here on this one. I'll do number 45 because it's like that. In number 45, you know a 13 and 8 and the angle between them. If that's all you know of the triangle, you can still find the area. Because the area is equal to 1/2 leg times leg times the sine of the angle between. Not just the sine of any angle, it's got to be the angle between those two legs. So it's 1/2 product of the legs times the sine of the angle between them. One last time, Connor,
Yeah.
can you put in 0.5 times 8 times 13 times the sine of 35 and see if you can match Connor. I mean, Colin, you should be able to match Connor. You are, Connor.
I got 29.83.
All right, can you show her the setup on that? Is that good?
Yes.
Colin approves. 29.8. All right. Avery, could you walk over here to the assignment board? Tomorrow we'll be checking this 4-7 1 to 26. Told you about it last Friday already. I feel like you should be past that at that day, but if you like to leave things pile up to the last minute, that's up to you. On Wednesday, we'll be doing checking 4-7 27 to 50, which includes what we just learned today. And we'll be taking a little quiz on 4-7 that day. And then you'll have to get going on that chapter 4, 1 to 73. That's 73 problems at the end of chapter 4. So I would say you should try to get a jump on that. One of these days or nights you're going to have to do a whole bunch. You kind of can pick when it is, but there's your deadlines. Over and out.